Okay, number one. So the first thing that we do, as you guys know, is we are going to replace everything with sine or cosine. First, I'm going to rewrite these as I like to do really quick. Okay, so tangent is sine over cosine, right? And since we're squaring the tangent, then we're basically squaring both of these. Cotangent is cosine over sine, and once again we're squaring it. Secant is 1 over cosine, and once again we're squaring it. And cosecant is 1 over sine, and we're squaring it. All right, so there's that. Now, in this case, we have two fractions on both sides, but what we're going to do is we're going to go ahead and combine these fractions so that we can kind of get the two sides to match, because even though they both have two fractions, they're not the same fraction. So by combining them, I think we'll find some stuff, interesting things can happen along the way here. So here we go. So I need a common denominator. So what I'm going to do here is I'm going to multiply both sides by sine squared. Oops. And then for this fraction, I need to multiply the top and the bottom by cosine. Cosine squared, that is. Okay, so now they have a common denominator here, right? I multiplied them by what they needed. Now we've got to work on this side. So for this side, for this fraction to match this one, I'm going to multiply the top and the bottom by sine squared, which is going to give me the following. And for this one, we're going to multiply the top and bottom by cosine. And then we're going to go ahead and combine the fractions together here. So we end up with, so sine squared times sine squared is going to be sine to the fourth. I'm going to go ahead and just write that for now. And then minus these two. Cosine squared times cosine squared is cosine to the fourth. All right, and on this side, we have sine squared minus cosine squared. Okay, and so now at this point, we have a little bit of a dilemma. The fact is that the denominators actually match completely. The problem is the numerators don't quite match. These are to the fourth power, and this is to the second power. So at this point, I'm kind of doing you guys dirty here. I did not show you how to do the next move that's going to help us get through this. I'll show you now in the video. Consider it a nice sneak peek into our lesson that's coming up in our next class or two, actually. But if you got this far with your homework, you're still getting credit. That's fine. But anyway, after I show you this move, I'm going to show you something else you could do that's like 10 times easier than this whole process. But once again, it's not something I showed you. I did give you the information for it, but I didn't tell a lot of you guys to go this route. But anyway, so first of all, what are we going to do about this? How are we going to get the left side now to match the right side? We have fourth powers on the left side, and we have second powers on the right side. So how are we going to do that? All right, well, the answer is we're going to factor it. Let me show you what I mean. Are you guys familiar with, well, of course you are. You should know the rules for the difference of squares. If you factor this, you get a minus ba plus b, right? So that's the difference of squares rule. Now, in case you didn't notice, that's what these things are down here. These are differences of squares. Let me give you an example. Suppose I had x squared minus 16. If I wanted to factor that, it would be x minus 4 and x plus 4, right? Well, we're going to change gears here a little bit. And how about instead of x to the fourth, or sorry, x squared, let's say I said x to the fourth minus 16. So the difference of squares tells us we're going to take the square root of this. That's x squared. In other words, just divide the power in half. And take the square root of that, which is 4. 1's plus, 1's minus, right? That's just the difference of squares rule. Something we've seen quite a few times this year. All right. Well, we're going to apply that here. So that's the new thing. Is I haven't really shown you guys factoring of trig functions, but ironically, that's exactly what our next lesson is going to be. So you guys will get a little more of this on Thursday. But what I'm going to do is I'm going to apply the difference of squares to this. You're going to find something kind of interesting happens along the way. Now, if you guys want to try that on your own, I would say pause the video, see if you guys can apply the difference of squares to that, and see if you can figure out the rest on your own. If not, then you can watch. Okay, so here we go. Let me write down those denominators really quick. Those are not going to be changing in this process. This side I'm not going to do the difference of squares with, but I am going to do it on this side here. So if I did the difference of squares here, I'm going to take the square root of that, which means this sine x to the fourth, that's going to cut the power down in half. So it's going to be sine of x squared. And then that's going to go in the front of each set here. Next, we're going to take the square root of this one. That's going to be cosine of x squared. And according to the difference of squares rule, 1 is plus, 1 is minus. Now, what would make me want to do that? Well, I knew that I wanted the powers to be 2 and not 4. And so that's a rule that popped in my head that would allow us to have that. But also, I would ask you guys to look up here now and ask yourselves, do you see a Pythagorean identity? One of those is a Pythagorean identity. It's this one. And what does it equal? It equals 1. So basically, anytime if this is 1, 1 times this is just going to be that. So you can just ignore that piece. And now you can see that both sides are the same. So that was a little bit sneaky. Finally. All right, so that's the long and hard way, but just to kind of show you something kind of cool, you don't need to write this, but just to try to show you guys something kind of cool, the more you know, the more flexible you can be. And so I actually can solve this in just about 2 steps. Check it out. If I were to subtract the secant squared x on both sides, and I'm going to put that minus secant squared x over here. And we also have the minus cotangent squared x. And then if I were to add the cotangent to the other side, we end up with this, right? All I did was switch a couple of things around. But why is that helpful? Well, remember I told you there's other Pythagorean identities. I probably won't be using them, but you are welcome to. Well, let's take a look here at those. It seems that secant minus tangent is equal to 1, right? And cosecant minus cotangent is equal to 1, right? So if we come back over here to our problem that we were just looking at, lost it. Anyway, we had this, right? The signs are just opposite. It's the same thing as the identity, right? So if I just change the signs on both sides, we have positive secant, negative tangent. That means it's 1. And so is that. So they're the same. Okay? So there's a few tricks you can do along the way if you know them. But either way you look at it, I think number 1 was kind of dirty pool. Sorry, I didn't look at it carefully enough to realize that we would run into the issue that we did there. But hey, we can use it as a teaching opportunity. Let's go ahead and move on to number 2. Number 2 is a little bit more straightforward, a little bit more up our alley for what we learned. So here you go. First of all, so if we just follow through with all the stuff that we've learned so far, this should work out nicely. I'm going to change the secant squared into 1 over cosine squared. And I'm going to change the cosecant squared into sine of x squared. Now, over here, I'm going to distribute this into the parentheses, and I end up with cosine of x squared over cosine of x squared minus cosine of x squared. And on the right side, we don't like complex fractions. So what did we say to do about that? We said to multiply the top and the bottom by the little denominator, right? So in this case, those cancel. And I'm left with sine of x squared times 1, which is sine of x squared. All right. Well, cosine over cosine is 1. And at this point, we have a Pythagorean identity. See if you can find it. It's right here. 1 minus cosine of x squared is sine of x squared. So that one contains all the stuff we talked about. No tricks on that one. All right, let's go ahead and take a look at another one. All right. So we're going to change the cosecant squared, the secant, and this cosecant squared, all into sines and cosines. So cosecant squared is 1 over sine squared. Secant is 1 over cosine. And cosecant squared is 1 over sine squared. All right. Next, I'm going to multiply the top and the bottom by cosine to cancel out this cosine down here. So that's going to give me So the bottom's gone here. I'm just left with 1, so we don't even need to write that. And on the top, what I have is cosine over sine squared. And then cosine and cosine makes cosine squared. So if I multiply those together, we basically just end up with cosine of x squared over sine of x squared. This is another one of our strategies now that we're looking at. Notice on the left side we have 1 fraction, but on the right side we have 2. What we talked about in that case was we need to combine these 2 fractions into 1 by getting a common denominator. So I'm going to think of this 1 as a 1 over 1, and then my common denominator is the sine of x squared. So I'm going to multiply the top and the bottom of my 1 by sine of x squared, so it has the same denominator as the other fraction there. And what I end up with then is, after I combine the tops, 1 minus sine of x squared. I'll show my work up here. This side stays the same for now. This side we're combining now, so it's 1 minus sine of x squared over sine of x squared. And once again, you guys should see a Pythagorean identity there somewhere, and it's right here. That piece is equal to cosine of x squared, so we now have the 2 sides equal. Okay, there's that one. Let's do this one. Okay, so I'm going to change my tangent and my cosecant so that they are sines and cosines. So it's going to become 1 plus sine squared over cosine squared over sine squared. And notice we have a complex fraction, right? I've got a fraction inside of a fraction, and that was strategy 2 that we talked about on Monday. We'll get to that in a minute. For now, let's continue with strategy 1, just changing everything into sine and cosine. So I'm going to change cosecant now into 1 over sine squared. The bottom is just going to be cosine squared. Okay, and once again, that's another complex fraction. So on the left side, the little denominator that I don't like is this one, the cosine of x squared. So I'm going to multiply all 3 of these terms by cosine of x squared. So there, right there, right there. And here they cancel. That's why I did that whole process. So let's see what that would give us. So now this is cosine of x squared times 1, so that's just going to be cosine of x squared plus, these are gone, so I'm left with sine of x squared over these 2. All right, now let's do the other side. On the other side here, we have a fraction inside of a fraction, and so I don't like this little fraction's denominator here, so I'm going to multiply the top and the bottom by sine of x squared. In this case, these cancel, and I'm left with 1 over 1 on the top, which is just 1. And on the bottom, I'm left with cosine of x squared and sine of x squared. We're almost there. Notice the bottoms are exactly the same. The tops are not, but what is that? That's a Pythagorean identity. It's 1. So we can replace it with 1, and then they're identical, and we are done. Yeah, so that number 1 was a tricky one. The rest of them also are a little hard, but hopefully that was helpful to you guys. I think that was our last question, if I'm not mistaken. Let's see. Yep, that was it. All right, so I hope that was helpful, and we will continue our study of how to work with trig expressions tomorrow. See you guys then.